What if you could write less code and make it do more? Inheritance lets you build powerful class hierarchies that grow with your program without repeating your code. Hello coders, welcome to my channel. I am David, your guide to mastering programming. Inheritance allows a class to inherit attributes and methods from another class, promoting code reusability and extensibility. Class that inherits is called child class, while class that is inherited from is called parent class. For example, if I have a class named A, I will code classes later. Here, I just want to show you the syntax. And I have a class B, and if I want to tell Python that this B inherits from class A, I need to open the parentheses and in the parentheses write the class name. This means that class B inherits from A, which means A is a parent and B is a child class. Also important thing to mention is that all classes that you create inherit by default from the object class. But you don't need to write here the parentheses and pass here object because Python does that for you. Inheritance is useful when multiple classes share common behavior. For example, all animals breed, and now maybe I have multiple types of animals. For example, dog, cat, parrot, or something. All of them breed, and I don't want to repeat the breed function multiple times. I can simply code that breed function in that parent class and then pass that function by inheritance to all the childs. This way, I coded the class just one time and all of them inherited that class. Also, there are multiple types of inheritance. For example, this inheritance is single inheritance. Also, there is multiple inheritance. For example, if I here have class B and here I create class C, this C can inherit from both A and B. This is called multiple inheritance because C inherits from two classes. There's also a multi-level inheritance. That means that B inherits from A and then C inherits from B. As you can see, there is a hierarchy. A is the parent to B and B is the parent to C. So C is technically a grandchild to this A and A is a grandfather, or however you want to call it. Another is hierarchical, which means we have class A and both B inherit from A and C also inherits from A. And there is the fifth, which is called hybrid inheritance, which means you can combine any of the previous four. I just want to mention something. Python uses C3 linearization to resolve method calls when inheriting, but that's a more complicated topic and I will explain that in a separate video. For now, I will just talk about single inheritance. Now I want to show you how to method override or how to use the methods from a parent class. So if I have a class animal that has, for example, breed method and I want to print breed, I can simply write this. And now if I want to have a dog that inherits from animal, I can write this. And here I can also code that breed function. And first, let me show you that I don't need to code it, that it will work. That if you create a dog instance, you will be able to call the breed function. For example, if I create d to be dog, and I can simply call d dot breed. As you can see, PyCharm shows me that there is that function for the dog instance. Now when I run this, breed is printed just how we wanted. Now I want to show you that you can override this function. Maybe you want to modify that function. Yes, all of them breed, but not in the same way. And you want to change it slightly in your dog class. You can do that by simply writing the function with the same name and same parameters and write. They don't have to have the same parameters, but here they will. And now you can print dog breeds. Now when I run this code, you won't see breed, you will see dog breeds. As you can see, dog breeds. You can access the breed method from this animal class, but in your child class, you need to write another function before that. You need to write the super function and write dot. This super function allows you to use the functions from the parent class, which is in this case animal. So now you can also code breed. Not code, but call breed function. And now when I run this code, you will see breed and dog breeds. Breed and dog breeds. Important thing to mention is, for example, if I have a special method, init method, and I want to initialize, let's say, self dot, I don't know, let's say a to be animal, and now you want to create also initializer for your child class, and here pass, let's say, name, and you say self dot name equals name, and now you want to print self dot a and print self dot name. You may think that this will work because you think that init will automatically call this init from dog class will automatically call the init special method from parent class, but that's not the case. This init method doesn't automatically call the parent's init method. So when I run this, you will see an error. Dog init missing one required positional argument. No, this is not the error that I wanted to show you. Here I want to pass, for example, Jack. Attribute error. Dog object has no attribute A. Why it doesn't have the attribute A? Since we didn't create it. We didn't initialize it. But you can do that by writing here super, open the parentheses, write the dot, and then call the init method. Now this will call this init method from parent class. And now when I run this, you will see that everything will work perfectly. We will write animal and then Jack. As you can see, animal and Jack. Another very important topic is private, protected, and public attributes. How I can access them. Private attributes can't be accessed if I have, for example, a private attribute here in animal class, which is a parent class to this dog animal. I won't be able to access it here. For example, if I created here AA, I won't be able to call it here. As you can see, I have yellow outline. I need to mandel this name into animal and then write this. Now this will work. As you can see, it works. If I have a public method, I mean attribute inside this animal function that can be accessed inside the child class and even outside the child class anywhere in this code. But if I have a protected variable, by definition, protected variable can be accessed inside a parent and a child class, while private can only be accessed inside the parent class, which means I here write, for example, self dot b to be equal to, I don't know, let's say 3, like, I don't know, it doesn't matter. And here I can write print self b. This will work. As you can see, animal and Jack is printed and 3 is printed. Important thing to mention is how Python sees these two functions. I mean, these two classes. What object is instance of which class? For example, I'll reduce the code so it doesn't confuse you. I just need the connections between them, this inheritance. If I have D that is dog, and now if I write print is instance of animal, this checks if D is instance of animal, or it checks if D is child of this animal. So, for example, if I write D and the dog here, this will check. Is D instance of dog? Yes, it is. So this should print true. But here, is D instance of animal? No, not directly. Is D a child of animal? Or in other words, is this a parent of this instance D? Yes, it is. which means when I run this should both print true. As you can see, true and true is printed. But if I create animal class, this will check. Is the instance of animal? Yes, it is. Is the instance of dog? No, it's not. But is the a child of dog? No, it's not. D is animal and D is parent. So this should print false. Now when I run this, true and false is printed. So the connection works just in one way. That's the important thing to remember. This will confuse you a lot, but with a lot of practice and constant repeating, you will remember it. I hope you found this video helpful. Like and subscribe for more coding content. See you in my next video. Until then, keep coding.